This is Unit 9, Lesson 8, Direct, Inverse, and Joint Variation. In order to learn these three different types of word problems, the easiest thing to do is to just get into some examples. So the first thing you need to be able to do is memorize these formulas. The direct variation of formula is y equals kx. The inverse, or another word for it is indirect variation, is y equals k over x. And the joint variation equation is y equals kxz. In these examples, k is your constant of variation. When you find k, and usually you have to do two different parts of the problem. First, you'll be finding k. Then you'll plug k into the original equation and then find either x or y, whichever they're asking you to find. And sometimes your variables won't be x and y, there'll be other things based on what the problem is asking for. So k will be your constant of variation. That constant will be the same for every part of the problem. So once you find k, it will be a constant and it will be consistent throughout the problem. It's very important to understand how to interpret the reading in one of these problems. So if the problem says y varies directly as x, this is what you would write. Y varies directly as x is y equals kx. If the problem says y varies inversely or indirectly as x, you would write y equals k over x. If the problem says y varies jointly as x and z, you would write y equals kxz. So the k for all of these different examples is your constant of variation. The other variables we will find as we work through the problem. So again, I think the easiest way to deal with these problems is to just do some examples. So that's what we're going to do here. You're probably going to lose my video as I go through this problem as I start writing with the pen, but that's okay. You don't need that. For the first one, it says y varies directly as x. So y varies directly as x. If y equals 10 when x equals 5, find the constant of variation. So the first thing we're going to do is find our k value. So k is our constant of variation. And then find the value of x when y equals 28. Okay, so y varies directly is what it says. So if y varies directly as x, that means y equals k times x, because varies directly is kx. If y equals 10 when x equals 5, this first bit of information is giving us the information we need to find k. So y is 10, I'm just going to start replacing. When x is 5, I don't know what k is, but I'm replacing y with 10 and x with 5. And then if I solve this, I'll get k equals 2. So that's the first thing I have to find. Once I've found my constant of variation, I will plug k back into my original function. So my function will be y equals 2x. That's my direct variation equation. And now they're asking me to find the value of x when y equals 28. So if y is 28, and I just do a little simple algebra here, x is going to be equal to 14. In order to get this problem correct, you would need to have four things. The original function correct, y equals kx. The next thing you would have to do is find the value of k, then plug that value of k into the original function, and then find the final thing that they were asking you to find. Y varies inversely as x. Well, we know from earlier, if it varies inversely, that is y equals k over x. If y equals 18 when x equals 2, find the constant of variation. So this is going to enable us to find our k value. So y is 18 when x is 2. So I replace those values in. If I do a little simple algebra, 18 times 2 is 36. So our k value is 36. I'm going to then take that and plug k into my original function. Now I want to find y when x is 12. So I'm going to replace x with 12. And 36 divided by 12 is 3. So y equals 3. Y varies jointly as x and z. That formula would be y equals kxz. It says y equals 40 when x equals 2 and z equals 4. This information will enable you to find your constant of variation. So y is 40. We don't know what k is. X is 2. Z is 4. So 40 equals 8k, leaving us with k equals 5. I'm then going to set up my function with the k value in there. Y equals 5xz. And for the last part, it says find z if x equals 5 when y equals 50. So I'm just going to sub in again. Y is 50, x is 5. So 50 equals 25z. That means z will equal 2. So now let's get into some problems that are very similar, but they might play with the wording a little bit. This one's a little bit different. It says y varies directly. So if it's a direct variation, we know it's of the form y equals kx. But this one doesn't say y varies directly as x. This says y varies directly as the square of x. Now let's think about what that means. The square of x is x squared. Okay, so if y varies directly as the square of x, instead of having y equals kx, we're going to have y equals kx squared, because y varies directly as the square of x. And then everything else from this point is very straightforward. If y equals 4 when x equals 8, we're going to plug those values in. So here we have 4 equals 64k, and k would be 4 over 64, which is 1/16. Then I'm going to plug my k value into my function. So y equals 1/16 x squared. And now I'm going to try to answer the question. It says find y when x equals 2. So y equals 1/16 times 2 squared. 2 squared is 4, and 4 times 1/16 is 4 over 16, or 1/4. Y varies inversely as the square root of x. Again, they're playing with the words here a little bit. Y varies inversely would be the k over x form, but instead of k over x, now we have k over the square root of x. So you see how they're playing with the wording a little bit here? It's not any more difficult than before. We just have to be very careful when we're reading these to make sure we're plugging in correctly. If y equals 4 when x equals 8, that will enable us to figure out our k value. I'm going to multiply by square root of 8. So we've got 4 square root of 8 equals k. Now remember, 8 can be simplified to 2 square root of 2. So we would have 8 square root of 2 when that's simplified. So k is 8 square root of 2. I'm going to replace k with 8 square root of 2. And now it says find y when x equals 2. So if I replace x with 2, notice these two things cancel out right here, leaving us with y equals 8. This one is different because now our variables are going to represent something other than x and y. Here it says the area of a circle is directly proportional. Now, when it says directly proportional, that is the same thing as a direct. It varies directly. Okay, so we can say the area of the circle varies directly. That means the exact same thing. To the square of its radius, that's the same thing as saying varies directly as the square of the radius. Okay, so the area, I'm going to say A is my area, varies directly as the square of the radius. Well, the square of the radius, wouldn't that be r squared? So area varies directly as r squared. A equals k r squared. If a circle with diameter 4 has an area 4 pi, find the area of the circle with diameter 7. Well, there's one problem here. This problem, when it's giving us values, is describing diameter, our formula says radius. So what is the relationship between the diameter and radius? Hopefully you remember from geometry, the diameter is twice the radius, or the radius is half the diameter. So for this one, if the diameter is 4, our radius is going to be 2. A common mistake for a problem like this is people put 4 in for the radius instead of 2. They just forget to simplify that, so be careful there. So if a circle with diameter 4 has an area 4 pi, we can plug that information in to solve for k. So area is 4 pi, so I'm going to plug in 4 pi equals k times 2 squared. So that is 4k equals 4 pi. So that means that if we divide by the 4, k is pi. So if I plug k back in, my area is equal to pi r squared. So all they're doing here is they're using direct proportions or direct variation to define the formula for the area of a circle. Then it says find the area of a circle with diameter 7. Well, we're trying to find the area. So A equals pi. R, if the diameter is 7, wouldn't R be 7 over 2? So we got 7 over 2 squared. So my area is equal to pi times 49 over 4. Remember, when you square 7 halves, that's 7 halves times 7 halves. 7 times 7 is 49, 2 times 2 is 4. And we can just simplify that as 49 pi over 4. In the next one, if F varies directly as R and inversely as S. So F varies directly as R would be F equals KR, but then it says and inversely as S. Well, if F varies inversely as F, wouldn't that be F equals K over S? So this just combines a direct relationship with an indirect or inverse relationship. It's okay to put them both in the same equation like this. Then it's pretty straightforward from here. We're just going to plug information in to find K, and then we'll use K to find the rest of the information. So F equals 20 when R equals 12 and S equals 15. We're going to solve this information to figure out K. So 20 times 15 is 300, and then 300 divided by 12 is 25. So K equals 25. So if K is 25, our formula will be F equals 25R over S. And now it says find F when R is 16 and S is 10. So we're going to plug that information in. F equals 25 times 16 over 10. 25 times 16 is 400, and 400 divided by 10 is 40. And the next one, according to Newton's law of cooling, the rate at which a hot object cools varies directly. So rate varies directly as the difference between its temperature and the temperature of the surrounding air. So if we think about this, the rate, I'll use R for rate. It's varying directly as a difference this time between its temperature and the temperature of the air that surrounds the object. So I'm going to say that I'm going to say that's T for temperature, and I'll say A is the temperature of the surrounding air. So Newton's law of cooling says that the rate, R, varies directly, so that would be K times the difference between the temperature and the air surrounding the object. And then it says, at the moment, a steel plate at temperature 260 degrees is placed in air that is 20 degrees. Its rate of cooling is 40 degrees. How fast is it cooling when the temperature is 110 degrees Celsius? Okay, so the first thing we're going to have to do is find K. In the first situation, they tell us at the moment a steel plate at temperature 260 degrees is placed in the air that is 20 degrees, its rate of cooling is 40 degrees. Okay, so rate is 40. I'm going to put 40 in for R. We don't know what K is. T was the temperature of the object. So it says at the moment a steel plate at temperature 260, so the object is 260 degrees, is placed in the air, so the air surrounding that object is 20 degrees, so that's minus 20. That will enable us to find K. So we have 40 equals K times 240. And then 40 divided by 240, that would be 1/6 for our K value. So if K is 1/6, that gives us the formula R equals 1/6 times the temperature of the object minus the temperature of the air surrounding the object. And now it says how fast is it cooling when its temperature is 110 degrees Celsius. Okay, so they're asking us to figure out how fast it is cooling. Well, isn't the speed the same thing as the rate? So they're wanting us to find the rate here. So the rate that it is cooling when the temperature of the object is 110, I could plug that in as 1/6 times, this time the temperature of the object is 110, minus the surrounding air. Now it didn't say that the temperature of the air has changed, so that would still be a 20 degrees Celsius. So to finish this problem off, we'll have rate equals 1/6 times 90, and 1/6 times 90 is 15. Now with this one, it would probably be good to put a unit of measure in. And the rate of cooling was 40 degrees Celsius per minute. So that's what we'll use as the rate of measure for our final answer. It will be rate equals 15 degrees Celsius per minute. I want you to go ahead and pause the video, see if you can figure out the answer, and then I'll come back and give you the answers in a few minutes. The heat loss through a glass window varies jointly as the area of the window and the difference between the inside and outside temperatures. So for my function, I have H equals KAD. It's a joint variation. If the loss through a 3.2 meters squared window, so that's my area, is 700 BTU per hour, so that's my heat loss, when the temperature difference is 12, so that's my D, I use that information to find K. I rounded to 2 decimal places, so that's 18.23 for my K value. Now, if you rounded to something different, you may get something slightly different with your estimate of your K value, but that's okay. As long as you're pretty close, we're good. And we're going to write our function with the K substituted in. So H equals 18.23 AD. And then for the second part, it says, what is the heat loss through a 4.4 meter square window? So that would be my area when the temperature difference is 15, right there. And we're trying to find H this time because it says, what is the heat loss? So if we're trying to find the heat loss, we just multiply these three things together. And that gives us the heat loss is 1203.18. I rounded to 2 decimal places again. And then notice here, it was BTU per hour for the unit of measure for the heat loss. So that's the unit of measure I use here, BTU per hour.